Alright, so this video we're going to look at graphing tangent and cotangent functions. And I left the D off and right there. That's A-N-D and. But anyway, so let's get started. We're going to graph tangent and cotangent. It's not difficult to do. Let me show you how to do it. So we're going to start out first graphing just y equals tangent x, just the basic tangent function. Now, we know that tangent is undefined at 90 degrees, and it's undefined at negative 90 degrees. So when you're graphing tangent and cotangent, you want to find two adjacent asymptotes. Okay, and the asymptotes, what I mean by that is they're just back to back, two asymptotes that are next to each other. Tangent has a vertical asymptote. Tangent x has a vertical asymptote at negative pi over 2 and pi over 2. Okay, when we get to cotangent, cotangent has vertical asymptotes at 0 and pi. All right, so we're going to use that to graph everything. So let's first look at tangent. So to graph tangent, let's draw this. Let's draw it right here. All right, so we've got vertical asymptotes at pi over 2 and negative pi over 2. All right, so there it is. All right, now what we want to do when we get our two adjacent asymptotes, so one at negative pi over 2 and one at pi over 2, all right, we want to break this up into 4 equal intervals along the x-axis here. So we need the midpoint of negative pi over 2 and pi over 2. And obviously that's 0. That should be easy for you to see that. So, but let me just go ahead and write it out so you can see it. So to find the midpoint between two numbers, you add the two numbers together. So that's negative pi over 2 plus pi over 2. That equals 0. And then you half that, which is 0, of course. All right. Then we need the midpoint between 0 and pi. Well, so to find the midpoint between 0 and pi over 2, we get 0 plus pi over 2 is pi over 2. And then we need to half that. So that's pi over 4. So this is pi over 4. And then we've got this one between 0 and negative pi over 2. So we're going to do 0 plus negative pi over 2 equals negative pi over 2. And then we half that, and that's negative pi over 4. So this would be negative pi over 4. All right, so that's drawing that on the x-axis. All right, and then we're going to mark off 1 and negative 1. All right, now the 1, just bear with me right now with the 1 and the negative 1 on the y-axis. You'll see as we work through the examples how that changes. Okay, you'll see that. But just remember, when you have just tangent x, it's just 1 and negative 1. All right, now this is the way you draw the tangent every time. So at this point right here, it's going to start out at negative 1, then it's going to go to 0, and then it's going to go to positive 1 every time. That's what it's going to do. And so when we draw it, it's going to look just like this. All right. Now that is graphing one period. Okay. Now what's the period of the tangent function? Okay, what's the period for tangent? Well, the period for tangent is pi. All right. Now, let's suppose that we didn't have just tangent x. It wasn't just an x right here. There was a number in front of the x maybe. How do we find the period? Well, the period is equal to pi over b, where b is the number in front of x. Okay? And in this case, the number in front of x is 1. All right? So, but this is how you would find the period. Okay? All right. So, let me erase this because I want to do a little more with this problem. We graphed it over one period. Okay? We graphed it over one period. And I want to graph another period. Okay? Let's graph another period. So to graph another period, we'll just continue on out this way. And if you wanted to, you could continue out to the left. It would be the same thing. But let's just continue out this way. So we're going to have another vertical asymptote right there. Now, how far apart are these vertical asymptotes? Well, they're, in this case, it's pi units. Okay, see, from negative pi over 2 to pi over 2, that's pi. That's the period. And so from this pi over 2 here, I've got to go over another pi units. So if I do pi over 2 plus pi, that's going to give me 3 pi over 2. And let me actually move that out just a little bit more. So let's maybe about right there. So at 3 pi over 2, I would have another vertical asymptote. Okay, and the way that I got this is I just added the period to this vertical asymptote here. And then what you would do is you would do the same thing. You would break this up into 4 equal intervals. So I would need the midpoint between pi over 2 and 3 pi over 2. So pi over 2 plus 3 pi over 2, that's 4 pi over 2, which is just 2 pi, which then I would need to half it, and that would be pi. So the midpoint there is pi. All right. Now I need the midpoint between pi over 2 and pi. So pi over 2 plus pi is 3 pi over 2, and then I would need to half that, and that would be 3 pi over 4. So I've got here, this midpoint is 3 pi over 4, and then I need the midpoint here between pi and 3 pi over 2. So I would have pi plus 3 pi over 2. And that's going to be, what is that, 2? That's going to be 5 pi over 2. And then half that. That's 5 pi over 4. And so this would be 5 pi over 4. All right? And then, just like I told you, then you just sketch it again. So remember, see at this first, see you're going to plot a point at the first one, the middle, and then the last one. So at this first one here, there's going to be a point at -1. Then I have, this would be at 0, and this one would be at 1. And so then your graph would look like that. And that's graphing it over 2 periods. And if you wanted to graph it over another period, you just go over another pi units, split that up into 4 equal intervals. Okay? So now that I've shown you that, how to do that, I'm just going to graph the rest of them over 1 period. Okay? Now, before we move on, we found the period. Okay? Now, I know on this one, to graph it over more than 1 period, we just, at this vertical asymptote, we added pi because that was the period. if the period, basically what you're doing, if you get your, once you get your two vertical asymptotes, then to get another one, if you want to graph it over another period, you just add not pi, but you add the period. Okay. In this case, the period's pi, so that's what we add to get to this vertical asymptote. But you add whatever this is. Okay. And it may be different in some problems. I'll explain that in the next one. All right, so what we want now is we want to know, okay, what's the equation for the vertical asymptotes? Okay, what would be the equation of the lines for the vertical asymptotes? So in this case, you can see we have vertical asymptote at pi over 2. So the vertical asymptote is x equals a number. Okay, so x equals pi over 2 plus, okay, so I want the equation for all the vertical asymptotes. See, we actually have vertical asymptotes at pi over 2, 3 pi over 2, negative pi over 2, and so on. But you can't list them all. So we've just got to get like a general formula for all of them. So just remember, we're at this vertical asymptote. Well, how do I get to this vertical asymptote over here? And how do I get to this vertical asymptote? Well, I'm going to add pi, right? See, I add pi to get to this one. I would subtract pi to get to this one. So I'm going to add pi times k, where k is any integer. And those are my vertical asymptotes. See, k could be 0, 1, 2, 3, -1, -2, -3. All right. All right, so let's look at the next example. So I've got y equals tangent of 2x. All right, so remember, to graph tangent and cotangent, you've got to get two vertical asymptotes, two adjacent vertical asymptotes. Now, we know with just tangent x, we had vertical asymptotes at negative pi over 2 and pi over 2. Okay, so to get the adjacent asymptotes, whatever you're taking the tangent of, in this case 2x, you set that equal to negative pi over 2, and you set it equal to pi over 2. Every time, whatever you're taking the tangent of, you set it equal to negative pi over 2, and you set it equal to pi over 2. And then you solve for x. So if I multiply this by 1/2, that'll get rid of that 2. See, I'm going to multiply everything by 1/2. So that's x is negative pi over 4. And here I get multiplied by 1/2. That's x equals pi over 4. So there's my two adjacent asymptotes. So let's draw this in. So I've got negative pi over 4, and I've got pi over 4. All right. And then I need to break this up into four equal intervals. So I'm not going to show the work on this one because it's similar to what I did on this one, breaking it up between negative pi over 2 and pi over 2. So I'll just write them in there. On this one, I'll work it out and show it for you. But on this one, we know the midpoint there between negative pi over 4 and pi over 4 is 0. The midpoint here would be what? Pi over 8. And the midpoint here would be negative pi over 8. And then this is going to be what? This is going to be 1 and -1. Okay? Just bear with me on the 1 and -1 right now. I think after we work the next problem, it'll make a little more sense. All right. Now let's sketch it out. So remember at the first point, that's going to be at -1, then it goes to 0, and then it goes to +1. And then we can draw our graph in there. And there it is. Okay. So before we move to the next problem, let's look at the period. So the period, that's what? Pi over b, which is pi over Okay, what's b? That's the number in front of x. So that's pi over 2. There's your period. Okay, is pi over 2. All right. Now, what's the equation for the vertical asymptotes? Okay, what would that equation be? Well, you can see I have a vertical asymptote at pi over 4. So I've got pi over 4 plus, okay, so how am I going to get to the next one? How am I going to get to this next vertical asymptote out here? What do I add to this? Remember, you add the period. So I'm going to be adding pi over 2. So that's going to be plus pi over 2 times k. And that would get me all the vertical asymptotes. And that's what I was talking about up here, you know, when we got to this vertical asymptote here. I want you to understand it's not that you're adding pi to get to the next vertical asymptote. You're adding the period, okay? And so that's what I was explaining here. To get to this one, this would be, if I drew this out, this would be pi over 4 plus the pi over 2. See, plus that period. And so that would be what was that? 3 pi over 4? Yeah. So this would be 3 pi over 4 right there. And that's what I was talking about. Okay. All right, so let's move to the next one. All right, so let's graph this one. All right, so first thing we got to do is we've got to get our 2 adjacent asymptotes. And remember what I told you. You take whatever you're taking the tangent of, set it equal to negative pi over 2, and set it equal to pi over 2. Every time. That's going to get your your 2 adjacent vertical asymptotes. And then I solve, okay? So now I solve for x. So I'm going to subtract pi over 2. So I get 3x equals negative, what is that? Negative pi. And then I divide everything by 3, so x is negative pi over 3. And then here, subtract pi over 2. So I'm going to get 3x equals 0, x equal 0. So there's my 2 adjacent vertical asymptotes. At negative pi over 3 and at 0. Okay. Now, see, this one would be easy to graph 2 periods because all we would have to do is what? Well, first, let's find the period. So the period is equal to pi over b, and in this case, b is 3, so that's pi over 3. So see, I would just have to go to pi over 3, and see, I would graph one period here, and then the second period here. All right. All right, so let's see what we've got. So now we need to what? Break this up into 4 equal intervals. So I need the midpoint here. All right, so that's what? Negative pi over 3 plus 0, which is negative pi over 3, and then a half that. That's negative pi over 6. All right. Then I need the midpoint here. So that's negative pi over 6 plus 0 is negative pi over 6. And then a half that. That's negative pi over 12. So negative pi over 12. And then I need the midpoint here. So that's going to be negative pi over 3 plus negative pi over 6. Well, let me change colors there so it'll all be the same. Negative pi over 3 plus negative pi over 6. That is going to be, let's see, that's going to be 3 pi, negative 3 pi over 6. So negative pi over 2, if I'm doing that right in my head. So 1/2, so I've got 1/2 times negative pi over 2 is negative pi over 4. So this would be negative pi over 4. All right, now let's take a look at this. Let me just write this problem down again so we can see it. So I'm just going to take the original problem here. I'm going to write it down here so I can see it. So I've got y equals, and that's 1/2 tangent of 1/2 tangent 3x plus pi over 2 plus 1. All right. Now, so normally what we've done is we've just drawn the 1 and negative 1. Okay, 1 and negative 1. Now, where did that come from? Well, that comes from the number in front of tangent. See, there's not a number, so it's understood to be 1. And same thing on the first problem. It's understood to be a 1. All right. But in this problem, in front, we have a 1/2. Okay. So we would, instead of marking off the 1 and negative 1, we would mark off the 1/2 and negative 1/2. Okay. That's how you get those numbers on the y-axis. However, this problem's a little different. Okay. If that plus 1, if the plus 1 wasn't there, then you would just mark off 1/2 and negative 1/2, do your points and draw it. Okay. But we've got the 1/2. So this is how I'm going to do this. I've got the 1/2. So I would go up to 1/2. Okay. That's where that comes from, the 1/2. But then this plus 1 here is shifting it up one more unit. So I would be at 1/2 plus the 1, which is 3/2. So let's do this. Let's do this, this, this. We'll call this 1/2, 1, and 3/2. Okay. So this point, well, I'm sorry. That would be what? That would be this point right here at 3/2. Now, what about this first point here? Well, it would start at negative 1/2, right? Negative 1/2, and then I would have to add 1, which would be 1/2. Okay, so normally it would be here at negative 1/2, but then because of this plus 1, that's going to bump it up 1 unit to the 1/2. So that would be right here. All right. And then this next point would be at 0, but the plus 1 is bumping it up 1 unit. And so my graph would look like this. So basically what it is, and let me just kind of sketch, let's just sketch this part without the plus 1. Okay, so I would have a negative 1/2 here. So this point, it would start out here, then it would go here, and then it would go to 1/2. And then you would draw this in, you would draw it in like this. Okay, and it would get closer and closer to the asymptotes. But what's happening is, you see this part of the graph here, that's the red graph. And then this plus 1 is taking that red graph and just shifting it up 1 unit. Okay, that's what's happening there. All right. I'm not going to try to erase those points. It'll erase everything else. But you know, that's all it's doing. So basically what you're doing is you're graphing this part right here. You're graphing that part right there, and then shifting it up 1 unit. Okay. All right, now let's look at cotangent. So guess what? Cotangent is graphed the same way that tangent is, except your two adjacent asymptotes. Well, your adjacent asymptotes are going to be at 0 and pi. And then it's the same thing. Okay? It's the same thing. Now, I have to do what? I have to split this up into 4 equal intervals. So I need the midpoint here. So that's going to be 0 plus pi is equal to pi. And then I half it, which is pi over 2. And then halfway between here, that's 0 plus pi over 2 is pi over 2. And then half of pi over 2 would be pi over 4. So that's pi over 4. And then pi over 2 plus pi would be 3 pi over 2. And then half of that would be 3 pi over 4. Okay? And I would be at 1 and negative 1. All right? Now, for cotangent, so remember, tangent started at negative 1, 0, 1. Cotangent, similar, except it starts at 1, then goes to 0, and then goes to negative 1. And then you just draw it in like this. And that's the graph. Okay? Now, and look at this, the period here, period's the same thing. The period is pi over b, so this would just be pi over 1, which is pi. Okay? And same thing, to get to the next vertical asymptote, what would you add to this? You would add to pi. So then your next vertical asymptote would be at 2 pi, and then the next one would be at 3 pi, and so on. Okay. Well, let's go ahead and write the equation for the vertical asymptotes. So we got a vertical asymptote here at 0, and then we're adding pi to it, right? So it would be 0 plus pi times k, which is what? Pi times k. And that's your vertical asymptotes. X equal pi times, x equal pi times k. All right. Now, I see up here, we found the period, but we didn't find the equation for the vertical asymptotes. So let's do that in this previous example. All right, so the vertical asymptotes would be x equal what? Look, we got a vertical asymptote here at 0. Use that. 0 plus. How do we get to the next one? What are we adding or subtracting? The period, pi over 3, right? So plus pi over 3 times k, which is pi over 3 times k. So my vertical asymptote would be pi over 3 times k. There's your vertical asymptotes. See, it's not that bad. It's not bad at all. All right, let's look at this one. So we got y equals 0.3 cotangent 2x plus pi over 2. All right, so just like we did on tangent, to find the two adjacent asymptotes for tangent, what did we do? Whatever we were taking the tangent of, we set equal to negative pi over 2, and we set it equal to pi over 2. Cotangent, going to be the same way, except whatever you're taking the cotangent of, you set it equal to 0, and you set it equal to pi. That's the difference, and the way you plot the points. Okay, so let's solve this. Subtract pi over 2 to both sides. I get 2x equals negative pi over 2 multiplied by a half. It's going to give me x equals negative pi over 4. Here I'm going to subtract pi over 2 to both sides. So I get 2x equals, what is that, just pi over 2. And then multiply by a half, so I get 2x equals pi over 4. So there's my adjacent asymptotes. Okay, negative pi over 4 and pi over 4. All right, so let's plot those. So I've got negative pi over 4, and I've got pi over 4. Break this up into 4 equal intervals. Well, the midpoint, we know that's 0 between negative pi over 4 and pi over 4 is 0. The midpoint here would be pi over 8. The midpoint here, negative pi over 8. Just like before, just add and multiply by half to get the midpoint between two numbers. All right, now, see this number in front, 0.3. So that's what determines this, 0.3 and negative 0.3. All right, and then cotangent starts here, then it goes to 0, and then it goes here. And so my graph is going to look something like that. Doesn't look very good, but you get the idea. Okay, now let's find the period of this thing. So the period is equal to what? Pi over b, which is pi over 2. That's the period. So if I wanted to graph another cycle, if I wanted to graph this over 2 periods, I would just add pi over 2 to the pi over 4 here, and that would give me another vertical asymptote out here. Then I would bust that up into 4 equal intervals, and then I would have it. Okay. Now let's get the equation for the vertical asymptotes. So that's x equal. So I've got a vertical asymptote at pi over 4. Well, how am I going to get to my next vertical asymptote? Well, I'm going to add or subtract pi over 2, right? So that's plus pi over 2 times k. And that's the equations for my vertical asymptotes. All right. So originally, that's all I had for this video, but I want to do one more problem. I'm just going to make it up because I wanted to show you something. So let's just do something simple. Y equals, let's do negative 2 tangent of, let's just say 3x. Okay, let's do tangent. I want to do it with the negative in front. Okay, so I've got 3x equal, so for tangent, what do we set it equal to? Negative pi over 2 and pi over 2. For cotangent, you set it equal to 0 and pi. So that's equal negative pi over 2, and I have 3x equals pi over 2. So for this, multiply by a third, so I get x as negative pi over 6. Here, multiply by a third, I get x equal pi over 6. So there's my two adjacent asymptotes. And so let's draw this in. So I've got negative pi over 6, and I've got pi over 6. And look, you know, while I'm working these, I don't know how many of you hung around this long in the video, but if you go search my channel for graphing tangent and search for graphing cotangent, so you would type in graphing tangent functions, graphing cotangent, search my channel. I've got more videos with more problems if you want to see more worked out. All right, so let's break this up into 4 equal intervals. So we know the midpoint here is 0. The midpoint here would be pi over 12, and the midpoint here would be negative pi over 12. All right, and then I would be what? I would be at 2 and negative 2, right? Because of the 2 here in front, or the negative 2 in front. That tells you how far to go up or down. All right, so we're graphing what? We're graphing tangent now, okay? Keep in mind we're graphing tangent. So tangent starts here. Let's write the problem. Y equals negative 2 tangent 3x. All right. So tangent starts here, but because of the negative in front, it's going to flip up to here. Okay, just like in sine, when you're graphing sine and cosine. If you have a negative in front of the sine or a negative in front of the cosine, it's the same thing. Okay, and then it goes to 0, and then normally tangent would go up here, but because of the negative, that's going to flip it down here. And so now we've got this is our graph. All right. So let's just, for fun, that's the main thing I wanted to show you on this example. If there's a negative in front, how it just flips it. So the period would be pi over b, which in this case is pi over 3. That's the period. And then my vertical asymptotes, well, I've got a vertical asymptote here at pi over 6. And what am I going to add or subtract to get to the next vertical asymptote? Pi over 3. So plus pi over 3 times k. And I think where k is any real number. And I think on the previous problems, when I wrote the vertical asymptote, I didn't put that where k is any real number. I know I didn't on this one, so it would be there. Where k is any real number, make sure you put that. Where k is any real number, I'm not going to write it all out. Same thing here, write it out there. And write it out here. I didn't do it on any of them, did I? Well, I did it on the first one. There you go. I don't know, just didn't write it. I don't know why. Got caught up in all the excitement, I guess. But yeah. But there you go. That's how you graph tangent and cotangent. Okay, and I think I said where k is any real number, where k is any integer. That's what I meant to say. All right, so video kind of turned into a mess there at the end, huh? I'm not saying the right thing. But anyway, you get the idea of how to graph tangent and cotangent. That's the important thing, okay? So just, graphing tangent, cotangent, sine, cosine, secant, cosecant, it's basically the same thing. You just got to get the period that you're going to graph it over, okay? Mark off those two numbers and then split it up into 4 equal intervals. And then for sine and cosine, you get your max and mins, right? Okay. If you don't know what I'm talking about, go back and watch the sine and cosine videos, graphing those. They're in this playlist. But hopefully this helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching. See you later.